Discuss in the previous discussions we have to discuss here what the type of electric potential we have to derive. The chapter number 2 we have to write here the name of the chapter, electric potential and capacitance and capacitance. This is the name of the chapter. And previous discussion we have to derive the definition of the electric potential. But now we have to see that what is the basic formula for the electric potential. In the previous lecture we have to derive the basic formula for the electric potential. V is equal to W by Q. This is the basic formula we have to derive in the previous lecture. Now we have to see that suppose this is a charge of plus Q and this charge produces its own electric field around it. If we are taking a test charge of Q naught, which is taken from infinity, this is the infinity. The infinity is not any term which is related to infinity, which is very larger distance from this charges, and this larger distance is called as infinity. But actually this is not an infinity because the charge is test charge Q naught is placed at very infinite distances. So here we see that this test charge will be placed at infinite distances. If we take this charge very infinitesimally small movement here, after that this test charge is taken from here, after that this test charge is taken from here, and after some interval of a time this test charge is enter in the region of this. If this test charge Q naught is entering in the region of Q, and this test charge experiences a force because there is a electrostatic repulsion between the test charges, because Coulomb's law says that this test charge will repel this in the direction of this, and this is an electrostatic force. That electrostatic force is given by Coulomb's law, and that electrostatic force is equal to Q naught. Suppose this distance is taken to be x and this is x square, and this is the electrostatic force which is to be acting on this test charge Q naught. If we are stopping these forces, so we assume a net external agent force that is to be applied at opposite to the direction of forces. So hence we see that a external force, agent force, that is similar magnitude but opposite in sense to be acting in this direction, because this is a external agent force and this is the same magnitude but in opposite senses, and this is the external agent forces which is to be applied on the test charge of Q naught. If this test charge Q naught will be placed at very slowly movement, have the very slow movements here, then we see that some amount of work is to be done by the external agent. If some amount of work is to be done by the external agent, so we have to derive what is the value of work done from the consuming here. So that we have to take simple work done is equal to F dx. This is the basic formula for the work done here. What is the value of the displacement? What is the value of the force that is to be acting on the test charge of Q naught? Q naught divided by x square. This is the agent forces, and this agent forces is to be minus sign because electrostatic forces is acting along in this direction and agent forces is acting along this direction, because this agent force is to be try to oppose this external and electrostatic forces. So now we have to see that if this test charge is Q naught, Q is displaced very slow distances of dx, and hence the dx should be multiplied here, and minus Q naught divided by x square dx. If we have to interested to know the total work done from the here, so we have to integrate on this system, because when we are determining the total value of the work done here, so we have to see that the total work done W is equal to minus Q naught integration minus 1 by x square dx. This is the value of work done here. Minus sign is taken from outside, and this should be taken here. Q naught. Minus sign is taken here, and this is 1 upon x square dx. And we are simply using the integration of here. The integration should be, this integration should be q naught minus 1 by x. What is the value of the limit to be considered? From r1 to r2. And limit is taken from r1 to r2, and limit is taken from r1 to r2. Placing these values, so we have to find the total value of the work. q naught minus sign is taken here, upper limit r2 minus lower limit r1, and work done is equal to q naught 1 by r1 minus 1 by r2. This is the net value of the work done, which is to be applied by the external agent to taking a charge from